Nope. Okay, let's start the last two problems of exam 2. Find the critical numbers of the function x cubed plus 6x squared minus 15x. Determine the local max and min. In order to determine the local max and min, we have to find the critical values. And we find the critical values by taking the first derivative. So f prime of x equals 3x squared plus 12x minus 15. And what we're going to do is we're going to set f prime equal to 0. So that gives me 3x squared plus 12x minus 15. And I need to solve. And those solutions will be my critical values. Looks like I can factor out a 3. And I can then factor what's left over. So that's what, x plus 5, x minus 1. That's right. And so my critical values will be negative 5 and 1. To determine whether they are local max and min, we draw our number line, plot the points, pick a point in each region to determine whether it is positive or negative. So let's pick, say, 2. Okay, so let me put this into the first derivative. Okay. Alright, when I plug in 2, I get 21, which is positive. Number between negative 5 and 1, say 0, I'll get negative 15. And a number less than 5, so let's say negative 6, I will get negative 6. I'll get 21, which is positive. So I'm going up, and I'm going down, then I'm going up again. So this would be a max, local max, and this would be my min. Alright then, so let me label these. Local max. Now this is a point, so it's going to be negative 5, comma, and then you're going to have to plug in negative 5 into the function, which I'm going to do right now. Right, and then it looks like I get 100. And then a local min is going to be 1 comma, and so if you plug 1 into the function, you're going to get negative 8, and that's it. Okay, suppose, let's do part B, suppose the domain has been restricted to this interval. Find the absolute max and absolute min. Now remember, the difference between absolute max and local max is that a local max could be a high point somewhere on the graph, but it may not be the highest point overall. So when I'm asking for the absolute max, I'm looking for the highest y value on the entire domain. So that's either going to be at a local max, one of the local maxes again, or it could be at an endpoint. Okay? Because the endpoint could be a max without actually being a local max. So what we're going to do is we're going to check the endpoints. So let's check negative 6. If I plug in negative 6, let's see what we get. I get 90. That does not beat out 100, so this is not an absolute max. And what was it? 1. So f of 1, let's see what we get. Oh, I'm sorry, not 1. That's not the endpoint. Apologize. X equals 5. That is my endpoint. So f of 5. Plug 5 in, and we get 200. Okay, so my absolute max will be at 5, comma 200, and then I have an absolute min which is 1, comma negative 8. It is the local min, but it is also the absolute min. And just one more time, you can be an absolute max without being a local max. And the example that you probably got in class would be something like this. And so here's like B and A. So here's a local max. And this would not be like, let's just, keep doing that. This would not be a local max, but on the interval from A to B, that would be a higher y value than this one. So absolute max, even though it's not a local max, but this is a local max. So hopefully that helped. That's the answer to our last problem on this exam. Any questions, please send me an email.